Hi, in this video we're going to be talking about related rates, which is basically an extension of implicit differentiation. Now, in previous videos that I've done, and as you've been learning in calculus, implicit differentiation is where we have a function relating x and y in an equation like x times y is equal to 1. And as we find dy dx, what we treated this was, we treated this as a product rule where y was a differentiable function of x. Okay, and just to go through this quickly, this is x times y. So it's the derivative of the first times the second, so this is y plus x times y, x times dy over dx is equal to the derivative with respect to x of 1, which is 0, and then we would isolate dy dx by subtracting y from both sides and having x dy dx equal to the opposite of y. And so here our derivative, as we divided this side by x and this side by x, derivative of y with respect to x is actually equal to the opposite of y divided by x. Okay, that was implicit differentiation, okay, where we treated y as a function of x. Now, related rates deals with the same type of a concept, only this time time is actually a big factor. Time is a big factor. And it's possible that we can have a function x times y is equal to 1, and both x, okay, where both x and y are differentiable functions of a third variable, like t, where t is most likely standing for time. Okay? And in this situation, we can find 4 different things. We can find y, we can find x, we can find the derivative of y with relationship to our third variable t, and we can find the derivative of y, the derivative of our other variable x with relationship to t. Okay? So this time, it's just an extension of implicit differentiation. Okay? So let's look at a problem right now. Okay? So we can differentiate something like x squared. Here, we can differentiate this. Take the derivative with respect to t when y is equal to 1 and x is equal to 1, and dy over dt is unknown. Let's say dx dt is equal to -2. Okay, so as we evaluate this with the derivative of t, the derivative with respect to t of x times y, again, this is still product rule, only now we're differentiating with respect to t. So what we're going to have is y times dx over dt plus, okay, so that was the derivative of the first times the second, okay, the derivative of x, well, that's just 1 times x to the 0 power, or 1, times dx dt, times our second function, plus x, our first function, times the derivative of our second function with respect to t, x dy dt, and again, that's going to be equal to the derivative with respect to t of 1, which is 0. Okay? So here now, y times dx dt plus x times dy dt is equal to 0. What we're going to do is we're going to solve for dy dt at these rates, or at these given conditions. Okay, so here I've got a quantity and another quantity, but this second quantity includes what I want to get to. So what I'm going to do is subtract y times dx over dt, which cancels is this, and I'm going to move it to the other side. Okay, so this leaves me with x times dy over dt being equal to the opposite of y times dx over dt. Okay? Now to isolate dy dt, get it all by itself, take and divide by x on both sides, and what we're left with is dy dt is equal to the opposite of y over x times that rate of the change of x with respect to t. Okay? Now, for us to evaluate this, we know actually y, we know x, and we know dx dt. So we can evaluate this as dy over dt is equal to a negative 1, because y was our 1 value, and x value of 1. Okay, and we're changing at a rate of a negative 2, and so dy dt is equal to a positive 2. Okay, so related rates, an extension of implicit differentiation. Again, now we're taking both of our variables and taking the derivative with respect to yet another variable. Okay, we'll explore this more in the next video.